Good evening, students. Ninth class second chapter name is polynomials and factorization. In that third subtopic, that is 2.3, its name is the degree of the polynomial. Under this subtopic we made 6 points. So already 2 points are completed. Now this is third point under this title. Its name is, third point name is the degree of the polynomials. These degree of the polynomials we made 2 categories. Among that, one is degree of the polynomial which contains one term. Second is, that is A. Now second one is B. Its name is a degree of the polynomials which contains more than one term. Okay? Alright? So what is first? A point. Degree of the polynomials which contains one term. This is a topic to discuss. Okay. In this we have to see 3 things, 3 points. But anyhow, either this one or this one, whatever that. But ultimate thing is we have to focus on this to decide the degree. What is that? Sum of the exponents of the variables is called a degree. Right? Let us see one by one. Think about 0. Now, first point I want to say, it is numerical term. 0 is a numerical term. So, 0 we can express 0x to the power of 2, 0x power 1, 0x to the power of 0, 0x to the power of 10, 0x to the power of 50, next 0x to the power of 100. Like that we can express many ways with the help of variables. No doubt, no? Right. Now if the question is raised, what is the question? What is the degree of the 0? Simple thing. Degree of the 0. So when 0 is expressed with 0x to the power of 2, so what is the degree? Degree is nothing but exponents of the variable is called a degree. Here sum of the exponent actually, but here one more exponent not there. That's why let us concentrate the exponents of the variable is called a degree. So based on the sentence, when 0 is considered 0x to the power of 2, then what about its a degree? It's a degree. Now I am writing here degree. It's a degree 2. Now, when 0 is expressed in such a way 0x to the power of 1, based on this, exponents of the variable is called a degree. Now tell me, what is exponent? 1. So 1 is called a degree of 0. Now, see, based on this, the exponents of the variable is called a degree. So that reason, it's a degree 0. Similarly, it's a degree 10. It's a degree 50. It's a degree 100. So we can write many ways. So 0 we can express in many ways. That's why I wrote here there infinity. Mean we can extend infinity ways. We can express infinity ways. Based on that, there are infinity degrees. If the question is, what is the degree of the 0? We can answer 2, 1, 0, 10, 50, 100. Because of 0 can be expressed in such a way. Based on that, we can answer degrees are 2, 1, 0, 10, 50, 100. I think understood. These are few examples to understand what is the degree of the 0. Few more observe. 0. I want to express 0 is 0x square. Better to take 0x to the power of Suppose 101. Now what is its degree? Degree is 101. Next, 0 we can write 0x to the power of 99. What is the degree of 0? When it is written like this, 99 only. 0 can be written as 0x to the power of 5. Now, when it is written like this, what is the degree of this? What is the degree of this? According to definition, exponents of the variable is called a degree. Your variable is x, its exponent 5. So that reason it's a degree 5. Next, 0x to the power of, for example, 15 there. Now, what is the degree of this? 15. No doubt, no? So, question is one only. What is that? What is the degree of the 0? Previous we answered 5. Now we are going to answer 4 more. When 0 is written like this, the degree is 101. When 0 is expressed like this, the degree is 99. When 0 is written like this, the degree is 5. When 0 is going to write like this, the degree is 15. Through this thing, we understood that, we conclude that actually what is the degree of the 0? Simple thing, students. 0 can be expressed in many ways with the help of the variable. So that reason, according to the situation, we have to answer the degree of the 0. In a sense, there are many zeros are there. There are many degrees are there of 0. If anybody are raising question, what is the degree of the 0? We cannot give proper one answer. Why? Because we can express 0 in many ways. Based on that, we can answer the degree. That is correct only. There is no mistake. But thing is, we cannot answer one single, unique answer. We cannot answer unique. Right. So that reason, the degree of the 0 is nothing but we are unable to answer. We are unable to say. We can't answer. Not define. However, we can answer. If anybody are asking what is the degree of the 0, we are ready to give answer. The answer is we cannot answer. We cannot find the degree of the 0. The degree of the 0 is not defined. The degree of the 0 is not determined. However, you can. Main strong reason is 0 we can express in many ways with the different exponents of the different variables. Based on that, they have different degrees. So that reason we cannot answer the degree of the 0 as a unique. So that the degree of the 0 is not defined. The degree of the 0 is not determined. The degree of the 0 is we cannot answer. In such a way we can comment. Ultimately, our final conclusion is that the degree of the 0 is not defined, not determined. Please note this point. Right? Okay. Okay. One more important thing. Concentrate. Here, 0 is called zero polynomial. 0 is called zero polynomial. Very important. Students, observe carefully. 0 is called zero polynomial. Why 0 is called zero polynomial? Because see, 0 is written 0x to the power of 101. So when 0 is expressed in such a way like 0x to the power of 101, so definitely this is what tell me polynomial only, no? I think understood. This is polynomial only. This is also one of the polynomial only. This is also one of the polynomial only. This is also polynomial. So 0 is expressed in such a way, so that reason 0 is called polynomial. In a sense, 0 is called 0 polynomial. But condition is you express 0 as the product of 0 into non-negative integral powers of the any variable. Non-negative integral powers of the variable. Suppose variable is x. Non-negative integral powers of the variable. Here variable x, non-negative integers as a power. Nothing but whole number only, no? In this you have to choose whole number. Whole number. The exponent should be whole number or else non-negative integer of the variable x. Then only 0 is considered 0 polynomial. Okay, na? Understood? Okay, right. Okay, right. Okay, let us see about second topic. What is second topic? Non-zero. In a sense, already 0 work is completed. No? 0 work was completed. No? Let us think about non-zero. Non-zero in a sense, see. For all a belongs to R, a is one of the real number. Every real number, nothing but for all a belongs to R. For every real number as a but condition where a is not equal to 0. Why? Because 0 work is already completed. So next why 0? That's why a for all a belongs to capital R, a belongs to real number where a is not considered 0. In a sense, its meaning is, its intention is, you choose any real number except 0. Okay, why not? Let us take 5. 5 is one of the real number only, no? Okay, let us concentrate its degree. Before that, this 5 you convert to algebraic expression. This is a numerical expression actually. 5 is a numerical expression. Better to convert to algebraic expression. Then only there is a chance to answer the degree. Otherwise, very difficult. Now, task is this 5 I am going to convert algebraic expressions. Listen carefully. 5 is equal to 5 into 1. No doubts. Now 5 into, instead of 1 I want to write x to the power of 0. This we discussed in powers and exponent topic. Everybody know very well about this. So instead of 1 I want to write x to the power of 0. Okay, super. Then try to multiply both 5x to the power of 0. Then what happened? 5 is equal to 5x to the power of 0. See, observe carefully. What happened? Numerical expression is converted to algebraic expressions. Now, concentrate what is the degree. See, degree definition is the exponents of the variable is called a degree. Now, what is variable x? Its exponent in 0. Nothing but the degree of 5, tell me, which is equal to 5x to the power of 0. Tell me, 0 only, no? Now you answer. The degree of 100, tell me. Yes, 100 also numerical expression. We have to convert to algebraic expressions like CMB 100. 100 is equal to 100 into 1. Yes, 100 into, instead of 1, I want to write x power 0. Now 100 into x power 0, 100 x to the power of 0. Then what happened? 100 is equal to 100 x to the power of 0. Now answer. The degree of the 100 is written, 100 is equal to 100 x to the power of 0. Now according to the definition, the exponents of the variable is called a degree. Here variable is x, its exponent is 0. So that reason the degree of the 100 is 0. One more question. The degree of 401. Very easy. This can be written as 401 x to the power of 0. So that reason its degree is 0. Okay, students. Right. Next. Few more discussion. Few more things. Let us go with minus 5. Better to take minus 12, which is belongs to real number. We have to choose the real number only. I took minus 12. It is last concentrate. Yes, minus 12. Minus 12. I want to write minus 12 into 1. Minus 12. Instead of 1, I want to write x to the power of 0. So that reason x to the power of 0. Next, minus 12 x to the power of 0. That means minus 12 is equal to minus 12 x to the power of 0. Now, question is the degree of minus 12. Tell me. Minus 12 x to the power of 0. It's equal. So its answer tell me 0. Why? Because variable is x, its exponent is 0. So that reason the degree of the minus 12 is 0. Next, few questions direct without calculation part. The degree of 110 0 only. Reason 1 is equal to 1 x to the power of 0. Right. One more question. The degree of 9 tell me. Yes, 0 only. Reason 9 can be written as 9 x to the power of 0. You know, previously we converted algebraic expressions. Now, one more question. The degree of 1000 tell me. 0 only. Reason 1000 can be numerical expression. We have to convert to algebraic expression. Like its algebraic expression is this one. You know how to convert. That means once again 1000 is equal to 1000 into 1. 1000 into instead of 1 x to the power of 0. Now 1000 into x to the power of 0 is 1000 x to the power of 0. What happened? Numerical expression converted to algebraic expression. So its variable is x, its exponent is 0. So that reason the degree of the 1000 is 0 only. I think understood. Next. See, fine. One more important thing I want to say. It can be written as 5x to the power of 0. 20. It can be written as 20x to the power of 0. For 50, it can be written as 50x to the power of 0. Next, 120. This can be written as 120x to the power of 0. In such a way, we can write many. Thing is, its a degree tell me 0. Its a degree 0. Its a degree 0. Its a degree 0. See, here 5, 20, 50, 100. Here 4 figures are there. These 4 figures are numerical expressions. We converted the algebraic expressions right now. You know how to convert. So this side their degrees. Okay, leave it. Degree is not a criteria here. So these 5, 20, 50, 120 we express in such a way. Let us see. What is actual polynomial? Polynomial is nothing but the algebraic expressions which contains the exponents of the variable is whole number. Yes, variable is x. Its exponent is 0. Variable is x, exponent 0. Variable is x, exponent 0. Variable is x, exponent 0. Nothing but according to the polynomial definition, the algebraic expressions which contains the exponents of the variables are whole numbers or non-negative integral powers. There no. 0 is a whole number only, no. 0 is a non-negative integer only, no. So that reason 5, 20, 50, 120 are best examples for polynomial. 5, 20, 50, 120, like that we can write main, are called polynomials. But which kind of polynomials? Those are called constant polynomial. Carefully observe, student. Constant polynomials. Those are called constant polynomials. Why they are constant values only, no? Constant figures only, no? Those constant figures are converted to algebraic expressions, no? After converting algebraic expressions, there is chance to answer degree, no? Yes or no? Yes. So these are called constant polynomials. Right? Let us see algebraic term. So its main fundamental is this one. What is this? Constant into finite number of variables. Nothing but variables you take just limited variables. Finite in a sense countable the variables. Finite number of variables are considered, and those variables contains non-negative integral powers. Nothing but whole exponents. Now I am taking few examples based on this. 5 into x to the power of variable is x, and finite number of variables, not only one, you take another also, one more, two more also. Let us take y, and their exponents. See, finite number of variables, nothing but variables should be countable, finite. So there are two variables are there, which contains non-negative integral powers. Nothing but powers should be whole numbers. For example, you take 3, here 2. Now this can be written as 5x power 3, y power 2. What is this? This is one of the algebraic term. Let us go with one more. Now 2 into x into y into suppose z there. Now in this, constant is 2, finite number of variables, here variable is x, y, z, their exponents, nothing but which contains non-integral, non-negative integral powers. The powers are powers of the variables. Here let us take 2, here take 3, here take 4. Now based on this statement, I arrange the exponents. See, constant there, finite number of variables, x, y, z are variables which contains non-negative integral powers. Nothing but the power should be whole numbers. So while multiplying both, 2 x square y power 3 z power 4. What is this? This is one of the algebraic term. Right. Last one. So let us take 1 by 2 into x to the power of 6 into y to the power of 3 into z. It's a multiplication on subset. 1 by 2 x power 6 y power 3 z power nothing there exponent, that's why better to take 1. So their product is this one. See, I took here 3 examples which are related to algebraic term, but based on this condition only, no? Yes, no problem. So this is a polynomial, this is a polynomial, this is also polynomial, because of they contains non-negative integral powers as the variables. Variables are contains non-negative integral powers. So mainly these three are called best example for algebraic term. But our topic is degree. What is the degree? Full-fledged definition. See, sum of the exponents of the variable. Here variables tell me. Now I am going to find a degree. Here variables x, y. Their exponents, x exponent 3, y exponent 2. Sum of the exponents nothing but 3 plus 2. What is answer? Sum of the exponents of the variable. Its exponent 2, its exponent 2. Their sum is 3 plus 2, that is 5. This 5 is called degree of this one. Next, let us see this one. What is its degree? Same. Here x, y, z, 3 variables are there. Their exponents 2, 3, 4. Their sum according to this statement. So the degree is 2 plus 3 plus 4, which is equal to 9. This 9 is called degree of this one. Now let us see third one. Its degree is equal to, so variables x there, y there, z there. Their exponents 6, 3, 1, and their sum. Sum of the exponents of the variable, nothing but degree is equal to 6 plus 3 plus 1. The answer is 10. This 10 is called degree of this algebraic term. So I want to give few more examples. Concentrate students, very important in exam point of view. One question: the degree of x square y. What is the answer? Yes, the answer is based on this sentence. The degree is equal to exponents of the variable 2, here 1. 2 plus 1. What is the answer? 3. Its answer is 3. Next question. The degree of x, y, z. Then same logic, same statement. Based on that, its exponent 1, its exponent 1, its exponent 1. 1 plus 1 plus 1, the answer is 3. This 3 is also called a degree of this one. One more question. The degree of three by 4 x square y z power 3. Yes, this is one question. What is the degree of this algebraic term? The answer is, according to this statement, sum of the exponents of the variable x, y, z their exponents, x exponent 2 there, y exponent 1 there, z exponent 3 there. According to this, sum of the exponent, nothing but degree is equal to 2 plus 1 plus 3. The answer is 6. This 6 is called the degree of this algebraic term. I think okay na beta. This is about first title, that is degree of the polynomials which contains one term. So till we discussed one side 0, one side non-zero, one side algebraic term. But here we concentrated one term, here also one term, here also one term, so that among these three situations we consider same one term only, and after taking one term we concentrated their degree based on this statement. Okay na? Right? Good. Okay students, special cases under this title, that is algebraic term. Special cases, special things, observe carefully. Number 1, star. What is that? Suppose let us take x. What about its degree? It is algebraic term. What about its degree? Its degree is 1. So next let us see x square take. What about its degree? Its degree 2. Now let us see x power 3. What about its degree? Its degree 3. Next let us go with x power 4. What about its degree? Its degree 4. Similarly, if you are going x power n, what about its degree? Its degree is n. Be attention, carefully concentrate the class. I told you special things. Special points, better to get special points. So x is one of the algebraic term. Its degree is 1 there. So that reason 1 degree of the algebraic term is called linear polynomial. What is its name? Linear polynomial. Only reason its degree is 1. 1 degree of the algebraic terms are known as linear polynomials. Why it is linear polynomial? Because of single reason, its degree is 1, that's it. Let us go with the second. Its degree tell me 2. So that reason its name is quadratic polynomial. What is its name? Quadratic polynomial. Quadratic in a sense degree 2. The algebraic term which contains the degree 2 is known as quadratic polynomial. The algebraic term which contains degree 1 is known as linear polynomial. So what about this case? The algebraic term which contains the degree 3 is known as cubic polynomial. Its name is cubic polynomial. The algebraic term which contains the degree 4 is called fourth degree polynomial. Fourth degree polynomial. Similarly, the algebraic term which contains the degree n is called nth degree polynomial. Nth degree polynomial. Okay students, this is the main title, main things under the title of degree of the polynomial which contains one variable. Okay, in this we got the new names. mainly linear polynomial, nothing but the algebraic term which contains the degree 1. And second degree of the algebraic terms are called quadratic polynomials. Third degree of the algebraic terms are called cubic polynomials. Fourth degree of the algebraic terms are called fourth degree polynomial. Dot dot dot. Nth degree of the algebraic term is called nth degree polynomial. Okay, na beta? Right. Done. Okay, students. Let us see B. That is second part. That is the second point as a B. Its name is the degree of the polynomial which contains more than one term. Now this is the time to discuss the polynomial which contains more than one term. Let us see one. More than one term. It should be polynomial, right? Now I am taking ax plus b, where a comma b belongs to constants. A comma b belongs to constants. So in this, how many terms are there? More than one term there, no? Yes. B is one term, ax is another term. There are two terms there mainly. But our intention is we have to take polynomial. Yes, it is definitely polynomial. Why? Because its degree is 1. Exponent of the variable is whole number. That's why it is a polynomial. So in this, it is a polynomial which contains more than one term. Yes, exactly. Here more than one term there, and it is one of the polynomial. But thing is, a comma b are constants. Now let us go with one more. Ax square plus bx plus c, where a comma b comma c belongs to constants. Here 3 also constants only. Here also same. It is one of the polynomial and it has more than one term. More than one term in a sense, maybe 2, 3, 4, more than that. Whatever that. Let us go with third one. Ax cube plus bx square plus cx plus d. In this, a comma b comma c comma d r belongs to constants. These are constants. Similarly, fourth one, see, ax to the power of 4, bx power 3, cx square, dx plus e. Here a, b, c, d, e belongs to constants. In such a way, we can write one more. A x to the power of n, an x to the power of n plus a n minus 1 x to the power of n minus 1 plus a n minus 2 x to the power of n minus 2 dot 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 plus a 1 x power a 1 x plus a 0. This is what I mean. It is one of the polynomial only which contains more than one term. But anyhow, we took few polynomials which are having more than one term. Just let us see the degree. Next task, what is the degree? Carefully observe degree of this one. See, the highest degree of the terms in a polynomial is called a degree. So it is a polynomial. Its a degree, tell me its a degree. 1. Its a degree, tell me. It is constant, no? It is constant, no? What about its degree? 0. Now I am writing. Here writing. Its a degree 1. Its a degree 0. Among these two, which is highest figure? See, degree of the terms. Here two terms are there. Two terms there. its degree is 1, okay, its degree is 0. Among the two degrees, degree of the terms, the highest figure is 1 only, no? This 1 is called degree of this one. Okay, right? Let us think this one. Here 3 terms there. So 3 terms. Yes, I made 3 boxes. Its degree 2. Its degree 1. Its degree, however, it is constant figure. Its degree 0. Among these 3 degrees of 3 terms, what is the highest degree? 2. So that reason its degree is 2. Let us think about third. In this total 4 terms there. That's why I drawn 4 boxes. Its degree 3. Its degree 2. Its degree beta 1. Its degree, it is however constant only, no? What about its degree? 0. So among these 4 degrees, what is the highest degree? 3. So that reason its degree, D indicate degree, its degree 3. Now let us see this one, 4th one. In this 1, 2, 3, 4, 5 terms there. So I want to draw 5 boxes. Yes, first its degree 4. The degree of this one 3. The degree of this one 2. The degree of this one 1. The degree of the E, it is constant 0. Among this, what is the highest degree? 4. So that reason its degree 4. Let us go with this last. In this we are unable to complete these columns. Okay, now yes, 100%. So what is the degree of this? N. What is the degree of this? N minus 1. There is no, I want to draw. Carefully listen. Yes. It is N. Its degree N minus 1. Its degree N minus 2. In such a way we can extend till constant figure. So among this, what is the highest degree? This one is highest degree. So that reason its degree is N only. Mean, students, be attention. This is 1 degree of the polynomial. This is 2nd degree of the polynomial. This is 3rd degree of the polynomial. 4th degree of the polynomial. This one, nth degree of the polynomial. Okay. Right. Once again, this is called 1st degree of the polynomial. So 1st degree of the polynomials are called linear polynomial. Recently we discussed. So its name linear polynomial. Now it is 2nd degree of the polynomial, no? So that reason its name is quadratic polynomial. Quadratic. P indicate polynomial. Now this one 3rd degree of the polynomial. So that reason its name is cubic polynomial. Right? What is this? It is 4th degree of the polynomial. Its name is 4th degree polynomial. So what about this? It is nth degree polynomial. What is that? Nth degree polynomial. Linear polynomial whose degree is 1. quadratic polynomial whose degree is 2, cubic polynomial whose degree is 3, fourth degree polynomial whose degree is 4, nth degree polynomial whose degree is n. One small important thing here, if here in nth degree polynomial, if an is equal to an minus 1 is equal to an minus 2, an minus 2, n minus 2 is equal to dot 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 a1 is equal to a0 is considered 0. In a sense, if the all coefficients of the variable is 0, then nth degree polynomial is convert 0 polynomial. Once again, very important, students. However, it is nth degree polynomial, no? If the coefficients of every variable is considered as 0, nothing but an is equal to an minus 1 is equal to an minus 2 is equal to dot dot dot, it is equal to a1 is equal to a0. These all are considered zeros, nothing but the coefficients of the variables are suppose 0, then nth degree polynomial is convert to 0 polynomial. In a sense, this total term is going to convert 0. I think got it. No doubt, no. Let us see few more examples. Yes, few more examples of linear. This is what generally now just we discuss, no? It is a linear polynomial. Now I want to give few examples. 2x plus 3. It is similar to this one, you know. It is best example of linear polynomial. Next, 1 by 2x minus 3, or else 1 by 2x minus 1, and x minus 1 by 2. These are best, etc. These are best example of linear polynomials. Now this is a quadratic polynomial. Now I am writing few examples. X square plus 4x plus 4, and one more example, x square plus 5x plus 6, etc. These are best examples of quadratic polynomials. Let us go with the cubic polynomial. X cube plus 3x square plus 3x plus 1. This is one of the example of the cubic polynomial. Like that we can write few more. Now fourth degree of the polynomial. Suppose x power 4, 3x cube, 4x square plus 5x plus 10. Like this we can write many. See beta, it is fourth degree polynomial, mean it is cubic polynomial example, it is quadratic polynomial, it is a linear polynomial. I think you got clear idea about the title B. What is the title name? Degree of the polynomial which contains more than one term. Okay students, if you have any doubts, please share your doubts in my comment box, and you share my videos to your friends or your neighbors, whoever, and like my video. And one more important thing, subscribe my channel. If you subscribe my channel, while uploading the videos, you will get direct notification from me. Okay, beta? Okay, thank you.